Good afternoon. Welcome to the session on digital economy. I'm grateful that you have taken time off your busy schedule to attend this masterclass. So the first session is I'm Adrian Roellin. I'm the head of the Department of Statistics and Data Science. Do we have the slides as well? I see. All right, there we are. And with me is Dr. Huang Yuting, who is a lecturer for at our department and teaches, among other things, the CET short courses, which are part of the SSG initiative. Okay, so let me talk a little bit about our Data Analytics Consulting Center. Now, full disclosure, I am not the director of the consulting center. The director is joining us online. She's currently in Australia on a vacation, and so I thought it'd be nice to, rather than having an online talk, it'd be nice to have someone here present in person and talk to you a little bit about the consulting center. I may not be able to ask all the questions in full detail. She'll be monitoring the questions online, if I'm not mistaken. I'm not sure whether she'll be able to answer them through MS Teams, but we'll see how much I can answer, and in case I can't, whether we can get a connection to her. All right. Okay, so the consulting center is actually is between the Department of Statistics and Data Science and Department of Mathematics. We're under the Faculty of Science at NUS. So let me first, before I start to talk about the consulting center, tell you a little bit about our department, which is sort of gives you the bigger picture of what we're doing and who we are. So our department was founded in 1998 as a fusion between mathematics, some people from mathematics, and the economics department, statistics people from these two departments, and then we were founded as the Department for Statistics and Applied Probability. Back in those days, data science was not a well-known term yet, and in order to avoid conflict with the Department of Statistics from the government, we had to add this and applied probability to our name. But then in last year we renamed ourselves to Department for Statistics and Data Science to sort of reflect also the trends in industry. So we have about 50 affiliated faculty members. That's a mix of researchers, full-time researchers, and lecturers, as well as practice track members. We have 3 undergraduate programs. As you can see, the Bachelor in Statistics, that's our traditional one that we've been running for over 20 years. And then for since a few years, we have been running the Data Science and Analytics program, and since last year, the Data Science and Economics program. So we have a total of about 400 undergraduate students per year. I mean, that's last year. Of course, before that, it was a bit less, but it's growing. And so this is quite attractive to our students. We're also running 3 graduate programs. The Successful Masters in Statistics coursework, there's about 200 students now per year that take that course. And we have, of course, a successful PhD program as well. We run short courses under the Continuing Educational and Training Initiative. That's what Dr. Huang is teaching, among other things. And then we have the Data Analytics Consulting Center, which to some degree they're not one under the other, but they are sort of collaborating. Okay, my online contact tells me that the volume online seems too low. Okay, has that been fixed? All right. Maybe I can hold my microphone closer, alternatively. Okay. A few words about data. Now, you may sometimes see that people say, "Oh, how much data has mankind accumulated up to now?" And I looked it up. It's in the order of what's called zettabytes. Okay. Now let me read you what a zettabyte is. 1 zettabyte is as much information as there are grains of sand on all the world's beaches. That's 1 zettabyte. And I think we're currently in a few dozens of zettabytes total of data. However, I always find that a bit funny statistics, because most of this data is actually just video data. Okay, a lot of data that goes across the internet is video streaming. because video takes a lot of, it's a very inefficient way of transmitting information actually, like Netflix, YouTube. So most of it is just video that is not really useful for, well, it's useful in some circumstances, but for the most, video data is not really useful. So this is sort of, has to be taken with a grain of, a pinch of salt, or a grain of salt. In a few years' time, I found this interesting statistic. We'll be in the yottabytes, and I can tell you what 1 yottabyte is. That's 1,000 zettabytes. As much information as there are atoms in 7,000 human bodies. That's an interesting statistic. I'm not sure how useful, but I thought that's quite interesting. Okay, anyway, the key point is a lot of companies, they accumulate data. And as a company, of course, you want to make use of that data, right? That's the key point. And the more data you have, you hope the more you can do with it and extract information. And that's what the consulting center in that sense can help you. Singapore, of course, has no natural resources, so data is considered to be one of our natural resources. And I once watched an interview or a speech by Lee Kuan Yew in the 80s. Unfortunately, I wasn't able to find that specific interview where he was talking about the information age, and it was quite impressive to me that in the 80s already it was clear that information age data is the way to go. But I found a speech by him that he gave in at the dinner in honor of the French Prime Minister in 1985, and he was talking to him and addressing him and says, "Yours is the responsibility to move the French nation into the electronic information age." So it was clear that at that point already to him that data is going to be the driving force of this century. Okay. Now about the consulting center, we're sort of 3 pillars that we have, which is on one hand the consulting center itself, the staff of the consulting center. At this point is Carol Hargreaves. We're planning to hire 1 more practice track person who helps us with these consulting projects. We have research fellows and research assistants and also students, and you can see that's on the top right. The other pillar are students, namely our data science analytics students are working on consulting projects that are coming from industry. Okay, that's the 3rd pillar. So the industry would come in with a consulting problem, with a paid consulting problem, and then we'll have the students work on that, of course guided by the consulting center's team. Okay. What we try to get out of it is, of course, we help the industry with their projects, but of course it's also a way to expose our students to real-world problems, to work in teams, to work on actual real-world consulting problems. And of course we can also use that to bring in case studies into our undergraduate curriculum so that other students can benefit from that as well. Okay? So that's the idea behind the center when it was sort of founded in 2017. We had a center before that was more sort of internal consulting, but we thought we turn this into a full-fledged consulting center and use it to help our students and expose them that way. Okay. So the consulting center, it's hard to say who they are. Well, Carol, as I said, is the director. We have research fellows and research assistants, but of course we have the whole department of statistics behind it with its expertise of many, many years. We have internationally recognized statisticians on the team. We have also parts of the mathematics department who help with the consulting center's projects. So in principle, the consulting center is, you have many years of experience in research and in consulting. Of course, the fact that we use students makes us competitive in terms of pricing, right? So we are not too expensive, but consulting costs money because we are actually paying the students as well. So they get like internship salaries, which we of course take from the industry to give it to pass it on to the students. Now, these are individual projects about which I don't know everything in detail, but the key of the consulting center is that because we have such a huge department behind it, we are sort of agnostic towards the domain. Okay, we have many experts from many domains, and that allows us to take in consulting projects from a huge variety of domains, from industry, various types of industries. Insurance, healthcare, so we have people working in these areas at the department. Hospitality, transportation, and this is the most recent project on synthetic data. Maybe we can tell a little bit about that, what the purpose of that project was. Now, often nowadays, I mean, data is sensitive, so you want to analyze the data, but when you give someone the data, you don't want to give stakeholders the data itself, but you want to give them something that looks like the original data. So what you might want to do is give external parties data that looks like your original data, but is not your original data. So you have, so that you can bypass issues with data privacy. And there's ways to do that, not straightforward ways of doing it. That's why you would need an expert, a consultant in data science who can actually help you with that. Okay, so that's one of the recent projects. So we can help, a consulting center can help with many things. For example, retaining customer, that's what I think Carol is one of her core expertise in terms of customer churning. How do customers leave or enter and leave a specific company, like telco companies, for example, to model that. So you would want to know if a customer joins the company, what is the chance that the person will leave the company within the next few months based on the demographics, for example, or based on the use, depending on the usage, and you might want to predict that. Okay, and so that's one of the things that where data science can help you. There's a lot of things we can do. As I said, we are flexible in the sense that we have experts from a wide field, and we can adapt. Maybe I should say what, I mean, in the old days, maybe 20, 30 years ago, sort of an important term was what's business intelligence. And business intelligence is more about, you have data and you want to present the data so that the decision makers can make decisions based on whatever metrics or whatever data you're looking at, or summary statistics. What the consulting center and what modern data science project is more about prediction, forecasting. You want to know what's going to happen based on your data that you have. As I said, for example, predicting what's the chance of a customer leaving a telco company, and before that happens, you may want to approach the customer and tell them, well, we have something interesting here for you, a goodie or a voucher or something of that sort, okay? Or probably the one that you know from your own experiences when you go to Amazon or Shopee, and you can see all customers have bought this or customers have bought that. That's also based on prediction, because you look at past purchases and you can say, okay, this person has bought this based on that profile, and you can make predictions about what's going to happen, and of course hopefully improve your business revenue that way. The consulting center also offers customized short courses. That means we don't just do consulting on the specific project. If the company wants to continue with that, of course it would be good to train the staff on that project from the company side on specific topics or skills. And so we also offer courses that we can customize, essentially. Whatever you need, we can try to accommodate for that. For example, data visualization in Python, that's a specific course that we've been offering, but there are others. Effective data-driven marketing strategies, HR analytics, and things like that. Okay, now let me tell you a little bit about things to think about when you start a data science project at a company. And this is Carol's list of 6 points that she wrote down. I'll try to explain you a little bit what they mean and the things to look out for. Number 1 is probably one of the most important ones, which is ensure quality of the data and data management. Okay, it is just a fact that before you can do fancy analytics, predictions, and forecasting, you need to have the data somewhere in good quality and in such a way that you can actually process it. You may know the term or heard of the term data engineering, and that's what all of that is about. Actually preparing the data and get it ready for so that someone else can actually do something with it, something useful with it. And that's just a fact, maybe 80% of the time is just cleaning the data and getting it ready. Number 2 is data centralization and make it accessible to the right people. Like I can see that in organizations like the university itself, we have a lot of data, but it's usually spread out different units, and usually each unit is quite protective of their own data, so it's quite difficult actually to get all the data that you need into a centralized place and then use it and have the right people get access to that data. Number 3, once you have the data, of course you need the right people to analyze the data. Now usually you can't just have a random person look at your data. So ideally you have an expert, and ideally at point 3, that's where the consulting center in particular can help you, where you have experts that can actually analyze the data and help you with that. Before you start with data, with analyzing data, often people have data and they say, okay, here is data, do something with it. That's probably the wrong approach. The right approach is, I have a business problem and I have some data. How can we address that problem with this data that we have, okay? Rather than just, I have data and I want to improve profitability. That's usually not the right approach. You need to have a specific question that you want to answer with that specific set of data. Or you want to, item 5 is, you may want to collect other data as well that you need in order to answer the question. So often it's not the data that you have is not actually relevant. There's a nice book, I think from the 90s, called How to Measure Anything. That's something I would recommend to anyone. How to Measure Anything. It is about companies often collecting data and writing reports that no one's looking at, whereas the main focus should be on other things that are not being measured. For example, having 1 million data points about something is probably not more useful than having 1,000 data points often, or 100 data points. That 100 data points about something that you haven't measured yet may be more informative than the other million data points that you have been collecting over years and no one's been looking at. Okay, sometimes just taking 100 random people and getting some data from them is more informative than millions of data that have been sitting around, that are not being used. So deciding what to do, what kind of data collect is important. And with 6, once you have that, you need to embark on the whole data cleaning process. Maybe you generate new what's called new data variables. That means you have maybe some combinations of old data that you can combine into new data that you can use then for prediction or as metrics or something. So that's sort of the circle closes back to 1. What happened? Okay. Something that is of interest to small companies is this enterprise transformation project by SSG, in particular the mentorship support grant that you can or that we can apply for you if you're interested to engage with us. And so I think it's up to $30,000 per project for up to 6 months that you can engage. I think the SSG funds up to 70 or 90% of that, and so you can engage our consulting center to in a specific project, and the project usually has to be or should be about transforming an SME towards digitalization in that direction. Yes. So this is something that we can do for you. So if you approach us, we can scale what can handle that and apply it for the grant. But NUS has a collaboration with SSG to get this done. Okay, so here are a sample of our partners and clients, and so maybe I should say what would the reason be to engage with the consulting center. Of course, it's not just to get a specific project done, but you can think of it as a more long-term venture, because once you have students working on consulting projects from your company, then of course that you have access to a pool of talented students who are trained in exactly what you need. So you may want to in the future hire these students as well. Moreover, there's potential for collaboration at the higher level, like research collaborations, which is what we're doing at this moment with other companies from industry. There's collaborations between, in that sense, for example, PhD supervision and things like that. That's a more high level collaboration, but this could be a starting point to engage with the consulting center and see what they can do, what our students can do, meet our team, and see that as a starting point then to engage further. For example, for more serious R&D and long-term collaborations. Okay, so I want to hand over to Dr. Huang. She's one of the CET lecturers, and she is teaching these short courses, among other things, where, yeah, maybe I should just hand over and then explain yourself. Thank you.
Right, thank you very much for your introduction. My name is Yuting Huang. I'm a lecturer from the NUS Faculty of Science. So, can I? So today I'm going to speak on how do we use continuous learning to reskill our employees, our staff, to so as to enhance the productivities within our organization. So now more than ever, organizations across different industries are becoming more and more digitalized. And as we can see, the ability to manage this torrent of data have actually been increasingly crucial in terms of the company's success. And we can already see big data analytics helping leading organizations in different industries to optimize their business performance and to optimize their business procedures. And if we think about it, the industry giants such as Amazon or Google have already been taken advantage of this many, many years ago. And some of the smaller but rapidly growing firms are also starting to use this as well. All right. So analytics systematically, big data analytics systematically help us to transform internal and external data into predictions, insights, or choices that help us guide our business decision making. Okay, so formally speaking, when we talk about big data analytics, we are referring to the technique for applying tools and applying analytical tools to structure and unstructured data for two purposes. The first one will be to recognize the patterns in the data. So if you think about it, when we try to segregate customers into different market segments so as to formulate some marketing mix, customize a marketing campaign for each of the group, that will be pattern recognition in the data. And another purpose will be to make predictions. As Prof. Roellin just mentioned, we can predict whether or not we can predict customer churning using the data we have. And formally speaking, in the context of data science and machine learning, prediction is an information output that comes from entering data inputs and running an algorithm. So what does this mean? To be more specific, we can think about some daily examples that every one of us must have experienced. So think about how we use Google Map. Google Map predict the best routes possible between any 2 points based on some data input. For example, the traffic condition, the weather condition, speed limit, the width of the road, etc., and etc. And then based on this input, the algorithm will predict which way will be the fastest to go and how long it will take. So this is how Google Map works. We can think about another product from Google, which is Google Search. So as long as we key in some letters into the search box, the algorithm will dynamically predict what we meant by simply just those 2 or 3 letters. So how does it make such predictions? It makes such predictions based on the data input on, for example, what the previous users have been keying in, as well as our own past actions. All right. So over here, as you can see on my slide, the examples can go on and on. It's a list that can never end. We have a lot of successful applications in financial business, telecommunications, travel industry, etc. And there's one more example that I would like to share today will be from the logistics and e-commerce industry. So think about this example from Amazon. I think in 2014, they have already patented something that is called the anticipatory shipping approach. So under this approach, the items will be packaged and pushed into the delivery network even before the order is made. That means a true indeed excuse me. That is indeed a peek into the future. So as you can see with big data analytics, operations, and specifically in this Amazon example, supply chain management can be a lot more efficient, a lot more productive, and a lot smarter. All right. So we have been sharing 3 different examples. And over here, the essence of all the stories are that big data are helping leading organizations transform their procedures and business performance. But such approaches are still the exception rather than the norm today. Actually, many of the companies acknowledge the potential that big data analytics can bring us, but they still cannot be able to apply this kind of analytics themselves. So according to one of the studies that I find out from the Harvard Business Review, it is a cross-industry study by the Harvard Business Review. On average, less than half of an organization's structured data are actively used in decision making, and actually less than 1% of the unstructured data are being utilized or analyzed at all. So companies obviously they acknowledge the potential of big data, but they are still not able to fully utilize it. So there must be something that have been holding them back. There must be something that is getting in the way between us and the future. So here I wanted to highlight 2 main challenges that companies are facing nowadays. The first one is the lack of capabilities, the lack of necessary skills among the existing business functions. If you think about it, many managers, even those with relatively high skill in relatively high technical skill, they do not have enough experience with data. So indeed, as a result, they won't be able to communicate their ideas effectively with the data team, and they won't be able to envision what might be possible with the data that are available in their hand. Okay, so that is the first challenge that companies are facing nowadays. The second challenge will be the lack of a structured approach to explore and evaluate and make sense of the data they have. So in the next few minutes, I'm going to tackle each of these challenges and then propose some of the ways that we can do to overcome these kind of challenges. All right. So the first challenge, if you still remember, is building necessary capabilities. All right. So to build the right data team, or just to build the right composition of any team, employees actually need unusual skills. So on the right-hand side of my screen, I have a diagram with 3 circles. On the bottom left, we have domain expertise. So this will mean a thorough understanding of the business procedures so that we will be able to identify what are the issues, what are the problems we want to solve, and which procedure we want to optimize. All right? But I believe in all organizations, we are no lack of domain experts. Okay, so this part is important, but I believe it is relatively easy to achieve. So what we want to focus on via continuous learning will be the next 2 circles: quantitative skills and programming skills. So by quantitative skills, I'm referring to the mathematics and statistics knowledge to guide the entire analytical process. So we need to have this skill to be able to understand how to measure the quality of the data, how to understand the rationale behind the model that we are trying to use, understand different performance indexes that tell us how good the model or how bad the model is, Also, it will help us understand how to tune the model parameters so that the model fit the data better or make more accurate predictions, right? So this is what quantitative skills will enable us to do. So for all of this to work more effectively or work more efficiently, at some point we will need to automate the process. We don't want to like repeat everything every single time. We want to automate the analytical process. Okay, so in the old days, this will mean the ability to write and develop codes quickly. But nowadays, with the help of statistical packages, employees can actually carry out those analytics without writing any single line of code. Okay, so that is what programming skills can bring us. We can either go the hard track, which is to learn how to code, and also we can learn how to use the statistical packages that are available to us nowadays. So over here, what I want to highlight is a close integration between the domain experts as well as these data experts. The experts equipped with quantitative skills and programming skills. And we will be able to build a bridge between the two, or we'll be able to attain this kind of skills via continuous learning. So in the slides just now, we talk about training existing business functions to become more data savvy and more comfortable communicating the questions or the ideas with the data team or with each other. So just now, Prof. Roellin talked about six steps to make sense of the data. And here is a 5-step approach what we want to use when you actually started the analytical project. First of all, we want the data team and the domain experts to work together to outline the entire business procedure so as to pinpoint the business problem. If we have a good understanding about the business procedure, we will also be able to understand the steps leading up to the issue and also the steps following the issue. All right, that is the first step. In the second step, we think about data collection and data preparation. And over here, regarding data preparation, we usually concern about the quality of the data. Right? And over here, the data team usually, they can follow some generic method to do some data imputation to deal with, for example, missing values or extreme values. But they can also work with the domain experts to come up with some imputation approaches that are more appropriate. All right? And before we feed the data into the model, we also need to understand how machine learning built a model. Okay, so machine learning builds a model by fitting or matching the output to a series of data input. And generally speaking, the number of input variables can be large. And in this case, we will need to adopt another approach that is called dimensionality reduction, which will try to engineer some different input combinations to generate some new features and stuff. Right? Then we come to analyzing the data. So over here, we can think about one of the most successful model over here will be the decision model in the retail business. Okay, so retailers gather information on customer behavior, such as the preferences and the spending patterns, so as to predict future outcomes. And along the way, we can also do some experiment with the customer, for example, to change the price or change the packaging a little bit, and then to observe what would happen in quantity sold. Okay, so that is the data analytical part. And then in the next 2 steps, we try to formulate our results and put our findings to work, which means we want to implement the output that we find. So over here, the appeal of the decision model that I just mentioned will be that we'll be able to make predictions, compare the prediction with what actually happened afterwards, and then we continue to update the model, continue to evolve the model, so that the model will be more and more accurate in the future. Okay, so the model is not only important at the particular time that it is built, we still get to update it over time using new data. Right? So these are the 5 steps, the structure approach that we want to follow when we are taking a data project. Right? Lastly, I would also want to mention that a successful data project is not only for data scientists. Having experienced or trained data scientists is simply not enough for a project to be successful. So we want to highlight the roles for non-data scientists in the organization as well. So by non-data scientists, generally speaking, I meant the regular employees, the employees without data in their title. All right. Even though they don't have a data term in their title, they are still essential in every single step that I just mentioned. So recall the steps we just described: understanding the problem, collecting, preparing the data, analyzing the data, formulating the results, and implementing the findings. All right. I would like to elaborate on how non-data scientists could play an essential role in each of these steps. First of all, in the first step, the non-data scientists or the regular employees plays a very important role to clarify the overall business procedure to the data science team. Without them, the data science project simply becomes a fishing expedition. Okay? And in the second step, when they are collecting and preparing the data, the regular employees should explain carefully how the data are defined and how they are collected. Because actually, it will be the non-data scientists who collect the data in most of the cases. So they know the best where the data comes from, how each of the variables are defined. Right? If we are not doing this part right, then there will be high risk that the data scientists do not understand the data, and then bad data simply lead to unreliable results. All right? So when we are actually analyzing the data, the regular employees should also participate in the discussion of the interim results. Otherwise, we may have very fancy results, but they are irrelevant or non-feasible, not feasible at all. So this is one of the part that regular employees should also take part in, right? And in the final 2 steps, we want to understand that while the output of any model can be very rich, but it will be of no use if we cannot implement them. Okay, so if you think about it, the non-data scientist will actually be the consumer of the results of any data outcome or any project outcomes. So we must collaborate with them and translate whatever finding we have to something that is tangible, something that we can take action on. Otherwise, the project stops with very, very fancy results, but with no business value. Okay, so these are the roles of non-data scientists that we want to mention. So over here, the essence is that well, we want to train not only the data team, but also the regular employees without a data in their title, because they play essential roles in every single step. All right. So in summary, we see that organizations or enterprises across industries are becoming more and more digitalized, and the competitive advantage is increasingly defined by the ability to manage, analyze, and make sense of the data. Today, in the session just now, I shared the opportunities that are presenting to us, the challenges that many of the companies are facing, and then what we want to do is to identify the gaps, the skill gaps we have, and fill the capability gaps. We can continue to train our employees for either data scientists or non-data scientists, and prepare our organization to embrace the full potential of the data and all the new technologies that are available to us. All right. Next, I'm going to spend 1 or 2 minutes to introduce the short courses that we are currently offer at NUS FOS. So over here, these are all tailored and 1-day or 2-day courses in quite digestible sizes courses offered in NUS FOS. We have courses ranging from introductory level or beginner level, the basic courses on the left-hand side of my screen, as well as intermediate and more advanced level. Okay, so if you are interested in any one of them, you can find the detailed description on our website. All right, over there. And all of the courses are eligible for SkillsFuture Singapore SSG funding. We also package our courses into 2 professional certificates. The first one is in data literacy for non-data scientists. Okay, so this will be a good package for the regular employees we have, and this will equip them with basic understanding of the concepts and applications in data analysis and visualization. In October this year, we are going to launch another professional certificate in data analytics and data visualization. So in this PC professional certificate, we not only have beginner level classes, but also have some more advanced level classes that provide a broader and deeper understanding in analytics and visualization. And lastly, in November this year, we are going to launch a program that is called SkillsFuture Career Transition Program, SCTP, in data analytics. Basically, we package 8 courses together. So over here, let me say something about it, some extra things. So I believe some of you have read in the newspaper that this is one of the nationwide workforce initiative by the SSG to support mid-career individuals in attaining industry-relevant skill sets. So the program lasts, the duration of the program will be about 3 months, and during the 3 months, you will take these 8 courses in a sequence, and then this will be instructor-led training sessions, and then in the end, we also have a supervised coaching session on industry-focused analytical project. Okay, you will be able to see a lot more information from the website over there on my screen. And if you have any questions, feel free to chat with us in the online Q&A session, or you can also write email to us. And thank you very much. That is all from us today. Thank you very much for your time.
All right, any questions? I mean, you can also ask the question in person. You don't have to do it through Slido. Yes, I think you have to talk in the microphone so that online participants can hear as well.
Yeah, just to check, right, so whether the consulting services also covers like areas like setting up data infrastructure, because many companies in the first place, we won't have sufficient data, or we won't even know what the data that we'll have. So does it covers that, or even down the deployment, right? If this is a successful, let's say, proof of concept, right, this pilot project that went out, so how do we eventually integrate it or integrate into our daily operations?
Okay, so I'm not sure I understand the question. So I would consider the consulting center services as a starting point. Maybe you want to prototype something that you can then, I mean, if you want to do it at a large scale in a large company, then probably consulting center doesn't have the manpower to do that. But if you want to explore something, prototyping, that you can then deploy and develop further within your company, then yes, the consulting center can definitely help. When you're talking about just infrastructure itself, then probably the consulting center is not the right unit, because then we're talking about data engineering mainly. The consulting center is more about analytics. Once you have the data, of course we can help and suggest how to collect the data and things like that. But when you talk about IT infrastructure, like what kind of software, what kind of hardware you need to collect the data, then that's probably we're not the experts for that. Does that answer your question? Okay. I just want to clarify, there are, I think the question's here. I just want to clarify, I mean, there are many ways to start engaging with us, as I said. A consulting project can be one through this initiative, maybe a small project up to $30,000 to see what we can do, what you get out of it, and then you can take it further from there. or internships. Usually internships are units that already have some data science capabilities so that someone can mentor the student. But the short courses as well, you can send employees into these short courses and see what they come back with. Right? So there's many ways to engage with us and then see what we can offer, what we can do, and then you take it from there. Okay, how does this work? I can't see it here, I can see it there. I think the one that is highlighted is the one I'm supposed to. Okay. Besides acquiring the programming and quantitative skills via courses and postgraduate study, is there any requirement for accredited certification for data roles? I am not aware of any, no. What is the title of the book you mentioned earlier? Okay, I think it's called How to Measure Anything. It's about the fact that you can sometimes just measure 100 data points and get more information out of it than measuring 1,000,000 data points, because the kind of the amount of information, every time you multiply by 10 the amount of information, you're not getting 10 times the amount of information. You're gaining maybe 2 times the amount of information. So that's the most gain is in the first 100 data points. After that, it becomes there's diminishing returns in how much time and energy you invest into more and more data. But of course, companies like Amazon, they have a huge amount of data. That's a different story. But for a company who starts with something, it is about the first 100 data points that have the most information that will determine how to proceed. Okay, can students from other departments seek advices from the consulting center? Yes, definitely. So short answer, yes. I mean, we have internal services, statistical consulting, the traditional one for research projects. That is, of course, available. That's available for free inside university. The challenge for data collection is to ask the right question to collate the right data. Any tips on how we can do that? Do you want to answer that question?
All right. Yeah, it's important to ask the right question, and if you understand your business procedure, you know, in detail, then we must be able to understand what are the issues or the problems that we want to solve. So that is the starting point. And then depending on the problem that you want to solve, for example, if you just want to describe something, then it will require a certain set of data. If your goal is to predict something, then it will lead you to different models, and that of course have different requirements on data. All right, and then if you want to optimize something, then you will require a different set of data. So basically, it depends on your understanding of the business procedure you have, the issue that you can pinpoint, as well as your goal or your aim of the analytical project. Right. So I hope that answers the question.
Maybe I can come back to the question about these accredited certification for data roles. I mean, that's what we're doing essentially, university, right? In that sense, we provide that certification in terms of master's degrees, in terms of bachelor degrees, in terms of CET course certificates, professional certificates. So the answer is yes. But at this point, of course, it's not necessary. It's not like you want to become a lawyer, you need this kind of credit or accreditation. That's not the case. That's why we have to proceed carefully, because I mean, many people can call themselves data scientists, but whether what they're doing is actually useful and meaningful is another question. So we have to be a little bit careful about it. Is the predictive analytics skills linked to artificial intelligence, such as machine learning? Should employee attend this course or other courses related to AI? Yes and no. It depends on the. It really depends on the question at hand. I mean, what kind of data you have and what's the question you want to answer. Artificial intelligence is just one tool that we can use to do predictive analysis. It's one of the tools. Of course, it's good to know. But just to be clear, when you start with this kind of project, it will not throw at it the most difficult or most sophisticated tool right away. You start with the basic one, get it running, and then you proceed from there. Okay? I mean, that's what I know people at Google, that's what they tell me. Look, they do internal consulting. They say we're not starting with the most sophisticated Google Mind Go, what is it called? The AlphaGo kind of software for a simple consulting project. We start with a basic statistical tool, and then we take it from there. Once that it's up and running, you can then iterate or make it more sophisticated. But of course, we've had, I mean, at the consulting center, that's the way it works. We start with a small project, and then the customer is happy, and then we gets to a bigger project where we can increase the sophistication of the methods used. Okay, but it's an iterative process. It's usually not people come and say, "Here's $200,000. We want a sophisticated something." That's not usually the way it works. Can share some success and failures from past consultation cases. When should a company engage and consult, or when not to? Unfortunately, I cannot tell you the successful ones, because we have signed NDAs with some of the successful high-value projects. Unfortunately, I would think Carol would be the better person to tell you all about that, successes and failures. I don't think she can join us, unfortunately, so I cannot tell you exactly about these projects. You'd have to approach her herself. I mean, you can go to the website, Data Analytics Consulting Center, and then see her name is there, so you can contact her if you want to know anything about that. When should a company engage a consultant, or when not to? I would say you just approach us, and then we'll take it from there. That's the key. That's, I think, the best recommendation. A comment instead of a question. Sometimes the right question is an iterative process. Start with a hypothesis and let the data support reject hypothesis. Exactly, that's what I'm trying to say. It is iterative in the sense, as I said, you start with measuring 100 data points and take it from there. What's in the data? Is that a way to go? And if not, you do something else. And of course, it's an iterative process, and you don't throw the most sophisticated tools at the problem right away. But you start basic. I think that's important. That the expectations are not that I want some AI sophisticated model throw at the problem, but start with the basics and then take it from there. Okay, I think that's probably all the questions. We're probably also running out of time. So thanks everyone for coming again. Hope you have something learned from this session. And as I said, if you have any questions, you can approach anyone from the department or the consulting center, and we can take it from there in a one-on-one talk. All right, so thanks a lot.